Hello everyone, myself Dr. Ramesh, working as a assistant professor, Department of Chemistry, Vardhaman College of Engineering. In today's session, we are going to discuss structure, isolation, properties of graphene and its applications. Graphene. Graphene is the basic structural element of carbon allotropes like graphite, charcoal, carbon nanotubes, and fullerenes. And it was isolated and characterized in 2004 by Jim and Konstantin Novoselov at the University of Manchester in 2010. They got Nobel Prize for this work. Graphene is the thinnest and strongest material known to exist in the universe. Due to these properties, graphene is called as wonder material. And one more point, graphene is a single atom thick, stronger than diamond, stretches like rubber, conducts electricity like conductors. The conductivity of graphene is much more higher than different metals like copper, iron, aluminium, etc. Isolation of graphene. For the isolation of graphene, one technique is there, that is Scotch tape technique. Scotch tape technique. Graphene is isolated from graphite by this technique. In graphite, carbon hybridization is sp2. Different layers in graphite held together by van der Waals force of attractions. In the graphite, mobile electrons are there. Due to those mobile electrons, graphite acting as semiconductor. Here, graphene isolation takes place from graphite. In this Scotch tape technique, we need to take graphite. On that graphite, we need to apply Scotch tape multiple times. By the application of multiple times of Scotch tape on graphite, single layer or mono layer of graphene is formed on the tape. Later, that single layer of graphene is transferred onto the silicon vapor. That is useful for various applications. This diagram showing how Scotch tape technique is used to isolate graphene from graphite. This is what graphite. Here we are applying Scotch tape on this graphite multiple times. Finally, we'll get mono layer of graphene like this. This is the process, or this is the process of isolation of graphene from graphite. Graphene. Structure of graphene. As like graphite, in graphene also, hybridization of carbon is sp2. sp2, the bond length of these bonds in graphene is 0.142 nanometers. But difference between graphite and graphene is, in graphite, number of layers are there. In the case of graphene, only one layer is there. That is single atom thickness, and one layer is there in graphene. Here the bond length between carbon and carbon is 0.142 nanometers. Actually, carbon electron configuration is 1s2, 2s2, 2p2. As we know that p orbital is divided into px, py, pz subatomic orbitals. Here in this case, p orbital having px1, py2, pz orbital is with empty, or pz orbital is empty. Here, in between carbon and carbon, sp2 hybridized orbitals of one carbon combined with other carbon sp2 hybridized orbitals will form sigma bond. The pi bond is formed by the sidewise overlapping of pz orbitals will leads to form pi bonds, or 5 bonds are formed by the sidewise overlapping of pz orbitals. Due to this reason, here electrons are transferred from one orbital to other orbital. Those are what? Pi orbital to pi star orbitals. Due to that transfer of electron from pi orbital to pi star. Pi orbital means pi bonding to pi anti-bonding orbitals. Graphene shows conductivity. Electron transfer from pi to pi star. Due to that reason, graphene shows electrical conductivity. Okay. Here, these two are sp2 hybridized orbitals. Mt1 is pz orbital. These pz orbitals combine with each other leads to form pi and pi star orbitals. Electron transfer takes place from pi to pi star. Due to that reason, graphene shows conductivity. Properties of graphene. Due to mobile electrons in graphene shows different properties. In that the important and first property is electronic property. Electronic property. As we know that graphene is zero overlap semi-metal, it shows conductivity due to holes and electrons as a charge carriers. The electronic property of graphene is due to highly mobile electrons. Highly mobile electrons. Electron mobility is fastest in graphene, which is 10 to 100 times faster than that in other materials. Next, the thermal conductivity of graphene is 2 times greater than that in diamond, 10 times higher than that in copper. Graphene is superconductive, ultra thin, conducts electricity 10 times better than copper and 250 times better than silicon. Mechanical strength. Mechanical strength of graphene is extremely higher than steel, that is 200 times harder or higher than steel. Along with hardness, it is very light material. Per square meter of graphene, weight is 0.77 milligrams. This is very less comparing with 1 square meter of paper. That is what? Paper is 1000 times heavier than graphene. 1 square meter of paper is 1000 times higher than 1 square meter of graphene. Even single gram of graphene, we can cover the whole football court, right? This image showing how graphene is stronger than other materials. Graphene can bear even elephant weight also. This image shows how the graphene is stronger than other materials, even steel also. One more point, graphene is elastic. It can stretchable up to 20% of its initial size. Optical property. Due to single atom thickness and highly mobile electrons, graphene absorbs 2.3% of white light. For this reason, graphene is used for touch screens of mobile phones and tablets. Chemical property. In general, chemical property depends on surface area. Here, the theoretical surface area of graphene is much more higher than other allotropes of carbon, like carbon black, carbon nanotubes. Here, the specific surface area of graphene is 2630 meters square per gram. This is much more higher than carbon black because of carbon black having 900 meters square per gram specific surface area and carbon nanotubes having 100 to 1000 meters square per gram. Comparing with these allotropes, graphene having high specific area. Due to that reason, the carbon atom which is present in the graphene or every carbon atom which is present in the graphene is ready to involve in a chemical reaction. And also, graphene having 2D structure. One is specific surface area, other one is 2D structure. Due to these two reasons, carbon atoms which are present in the graphene are ready to involve into the chemical reactions. One more point, graphene bonds at temperature range 350 degrees centigrade and above. Applications of graphene, in that first one is electronic and electrical devices. Graphene can be used as a coating to improve current touch screens for phones and tablets. It can also be used to make circuits for our computers, making them incredibly fast. Graphene is used to make circuits in computers to increase the fastness of the computer. Graphene could see a smartphone which you could wear on your wrist, or a tablet you could roll up like newspaper. By using graphene, we can make mobile phones like wristwatches and tablets which we can roll like newspaper. By using graphene, we can prepare small transistors. The first small transistor which is made by graphene introduced in Manchester University. The transistors which are made by graphene are working efficiently than other circuits which are made by traditional silicon based semiconductors or silicon based circuits. This image shows that one. This is a mobile phone which is made by graphene. Computers. Graphene is superconductive, ultra thin, conducts electricity 10 times better than copper and 250 times better than silicon. Because of this is a semi-metal material which can increase the speed of microprocessors. This is also tested by the researchers. This speed is 1000 times higher than other materials. Next, batteries. In general, lithium batteries are used in mobile phones and computers, etc. Lithium batteries are doped with, or lithium batteries are combined with graphene to produce other hybrid batteries. Those are what? Lithium graphene hybrid batteries. These lithium graphene hybrid batteries shows or holds higher energy during discharge and recharge very quickly comparing with lithium batteries. Here, in general, traditional mobile and computer batteries are made by lithium. Along with lithium, if we use some amount of graphene to make those batteries, we can decrease the recharge time of those batteries. Graphene lithium batteries are quickly recharged comparing with lithium batteries and holds more energy during discharge comparing with lithium batteries. That is the reason why soldiers use these batteries. Graphene based batteries also charged by even with body temperature, even in the presence of sunlight also. This image showing batteries which are made by graphene and used in tablets, phones and computers. Next one is biomedical applications. Graphene applications in biomedicine are numerous and can be classified into several main areas. In that, first one is transport or delivery systems, in sensors, tissue engineering and biological agents. Example is antimicrobials. These are the biomedical applications of graphene. COVID-19 detection. At the time of COVID-19, graphene is used to detect the whether COVID positive or not. Or in other words, graphene is used at the time of COVID-19 to detect the COVID-19 virus. That is what? SARS-CoV-2. These are the applications of graphene. In this video, we have covered isolation, structure, properties and applications of graphene. Thank you.